Hi, in this first module of week 2, we'll learn about solving linear first order equations. Um, and so before we do that, we need to know what's a linear equation versus what is not a linear equation, or as we call them, nonlinear equations. Um, and so let's get to that. Okay, so a first order equation, first order ODE, is something that can be written in the form as we've seen this before. dy dx is f of x and y. Okay, so we're thinking of f is the function that describes the differential equation, y is the independent variable, and x is the dependent variable. So we say, so let me call this 1. We say a first order equation is linear if it can be written in the form let's say um, capital P of x, y prime, I'll use y prime instead of dy dx, plus capital Q of x times y is equal to h of x. Okay. All right. So these are where P, Q, and H are functions of x. And maybe we don't know anything about them. Now we're going to need restrictions, or else, they can't just be arbitrary, really horrible functions, or we will not be able to solve the equation. But in principle, the differential equation can have any functions as coefficients. But the important thing to notice is that it's a function of x times y prime plus another function of x times y. And then there can be leftover stuff that only involves x, or constants could go in there. What you can't have is anything involving y multiplied times something else involving y. So any other form, so let me call this one 2. So if we cannot get our equation into the form 2, we say the equation is nonlinear. I use EQN for equation. Okay. So that's one of my abbreviations that you'll get used to by the end of the semester. And sorry, FCT is function for me, for shorthand. Okay. Another definition is that if h of x is identically equal to 0, we say 2 is homogeneous. Otherwise, if it's anything except 0 on that right-hand side, otherwise 2 is inhomogeneous. Okay, so let's do a couple of examples. So suppose I look at the equation x times y prime plus ln x times y is equal to x squared minus 4x plus 10. Okay. So notice you have a function of x times y prime and another function of x times y. And then over here on this right-hand side, we only have functions of x or constants. Okay, so this equation, this is linear because it's exactly in the form of equation 2. Okay, or you could tell capital P is the function x, capital Q is ln x, and h is x squared minus 4x plus 10. So that's linear equation. It's first order. because the highest derivative you got is first, okay, first derivative, and it's inhomogeneous. Because this side is not zero. Okay, you have a function of x times y prime plus another function of x times y, and this is not zero. So that makes it inhomogeneous. Okay. Here's another example. Suppose you had x y prime squared is equal to x squared minus 10. Okay. This is a nonlinear equation. Why is it nonlinear? Because you have a y term, the derivative, multiplied times itself. It's squared here. So that makes it nonlinear. So the methods we're about to learn will not work on an equation like this. Okay. And finally, let's write down one more example. Suppose we look at the equation y prime plus p of xy equals 0. Okay. So that's homogeneous because genius, it's linear because it's exactly the form we mentioned before, the equation we called 2, and that right-hand side is 0. And in a minute, we're going to learn how to solve not only equations that look like this, but equations that have an inhomogeneous term here. So that'll be the next video. So hang on, you'll see that in a minute.